Hey everybody, it's Brian here with another SPSS video. Today we're going to talk about the two-sample correlated groups t-test. So this is a little bit different than the two-sample independent groups t-test that we did in the last video. And that's because the data are structured differently. We're still comparing two group means to each other to see if they're significantly different. But in the correlated groups t-test, the samples have some sort of paired relationship with each other. There's a couple of different ways to have data with this structure. But one of the most common ways in social sciences is to ask the same people multiple times. You could either have like a before after, you ask them a question, and then you have some intervention, and then you ask them the same question again and see if their answer changed. Or, as we're going to do in our example here, we ask them two different questions that are on the same scale, and then we can compare to see if the average response to one question is different from the average response to the other question. One thing that is worth pointing out in SPSS is the data are structured differently for a paired sample or a correlated groups t-test compared to the independent groups test. So here I have our movies SPSS file open already. And we asked these people, we have 100 people, we asked them two different questions about movies. We asked them to rate the Lion King movie on a 1 to 10 scale. Then we also asked them to rate the Iron Man movie on the same 1 to 10 scale. How much did they like the movie? And so you can see here the data are structured differently because we have the ratings in one column for one of our groups and the ratings in the other column for the other group. When we did an independent samples test, we instead used some sort of grouping variable and all the ratings were in one column. So the fact that the ratings are split across two different columns is a tip-off that we're doing a correlated groups test instead of an independent groups test. So let's go ahead and do the analysis. So we're going to go to Analyze. We're going to do Compare Means. And SPSS calls our correlated groups test a paired samples t-test. So we're going to click on that. And then to set this up, we need to drag both of our variables over, both columns. And so we can click on the Lion King. We could do these one at a time or be a little bit fancy. And I can hold down Control and click on the other variable to select them both at the same time and then drag them over. It doesn't really matter what order they're in this dialog. And then we'll click OK here and take a look at the output. The first table here is just our descriptives for each of these two movies. What is the average rating? Looks like Lion King is a little bit higher than Iron Man. And we had 100 ratings for each because our 100 people rated both movies. Standard deviations for both of those samples. This next table shows, it does a correlation analysis, which we haven't covered yet this semester, but we will. It shows that there's actually a very high correlation. People who liked one movie also gave a pretty high rating to the other movie. And people who gave it a low rating tended to give it a low rating for both movies. But then here's what we're really interested in, the paired samples test results. So remembering when we did this by hand that we're calculating a sample of difference scores, and then we're seeing if that sample of difference scores is different from 0. And so this is telling us about our difference scores. Here's the average difference score, which we could also get just by subtracting the two means here in our descriptives. Here's the standard deviation of our difference scores. And then here's the standard error of the mean, but since it's of our difference scores, this is the standard error of the difference between means. Gives us a confidence interval for the difference between means, but I'm really interested in our t-test result. And here's the t obtained, 1.943. Degrees of freedom is n-1, so 100 minus 1 is 99. And then here's our p-value, our significance, 0.055. So we're just high to be able to say that this is significant at the 0.05 level. So we would say that no, there is no significant difference in people's ratings of The Lion King compared to people's ratings of Iron Man. That it seems like all these Disney movies have equivalent, or Disney-owned movies, I should say, have equivalent ratings from people. So that is the paired samples t-test, and I will see you guys in the next video.